Hey guys, and welcome to another of 4th's Advanced C++ tutorials. Last time we looked at the very basics of our Lua setup, and that's what I have open right here, is what we got done last time. So we were able to execute this main Lua script. Now, this time we're going to need to learn a little bit about Lua so that we can use that, those very basics for the rest of these tutorials. And the basics on how Lua works will influence a lot about how we think about the Lua hybrid. So, let's learn some of the basics of Lua. Say you have a language, and the first thing you're always going to ask is, you know, how do the variables and functions work in this language? What kind of, does it have, sort of our basic setup? Does a equals 1 do what I expect? And the answer is yes. We have our basic behavior for variables the way you'd expect them from a language like C. This is very C-like in a lot of ways. So I can just write a equals 1, b equals 2. I don't have to declare my variables like I would in C or C++. I can just say, take a brand new variable and use it. In fact, I can also take variables that don't exist yet, that haven't ever been set, and use them, because anything that has not yet been set is automatically set to a special value called nil. So a equals nil is already true before now. In fact, every variable you can possibly conceive is nil, except for the ones that are already set, like the print function is already used, so it's not nil. And there's other functions like require is not nil because it's already been set. So you've got your basic variable behavior. A equals 1 stores 1 in the variable a equals a plus 1. We do not have a plus equals 1 in Lua. Also, as you can see right here, our comments are not 2 slashes like they are in C++. They are 2 dashes. So that's a little something I'll have to get used to. We can also deal with strings pretty easily. Hello world. And as you've seen up there, we've got the print function for putting things out. We can put out any type, numbers, strings, they all print, and you can print as many as you want. Print's a variadic function that will print out each one in succession. So let's see that execute. There we go, to hello world. I'm not lying to you, that's the basics on how things work. Now, that's our very easy stuff. We also need some way to group values together to kind of combine things. We need a means of combination, and we also need a means of abstraction. Those are the two things that we really need in our language. So we've got our basic setup there. That's what we can do. What's our means of combination? How do we combine things together? We can use in Lua what's called a table. Now, if you know a scripting language like Python, for example, in Python you come with a lot of different built-in data structures. In Lua, all we have is the table. The table is a basic collection of pairs. So every key has an index, or like every key or index is paired up with an object. The keys can be numbers, they can be strings, they can be other tables, and so can the objects. You can make a pairing between anything except for nil. Nil cannot be a key. That's the one exception to every object is usable in every position. Any object inside the table can be paired up with nil. You just can't use nil as the key. That's the only rule. Now, the two brackets facing each other is our table constructor. That makes an empty table, and then I can add things to the table like so. And in general, the basic format, as you're seeing here, is table, key, value, right? And as I was saying, your keys can be in numbers, they can also be strings, like this, equals world. They don't have to match with each other, so we could do number 1 equals 1. We could do T4 equals 4, and so on. We can pair all these things up. we don't really have many other types of objects. Right now we have numbers, strings, and tables. So we can also say something like t2 equals table that's empty, and we can do t2 equals what's up. So there's our basic table behavior. Now that's not. I'm not going to print all this stuff out because we need to get through a lot. So that's our basic table, and that allows us to combine things. Now there's a couple of shorthands on tables we'll need to learn real quick. So this is a great way to create objects. We can make an empty table and make pairs between things, and that'll be useful for a lot of things. But what if we just want our tables to behave like objects? Do we have to go t x equals 0? Even I can't type this very fast. T y, keep hitting enter by accident, equals 0, and then t x equals t, whoops, come on now, t x plus t x speed. There. So I think that makes the point. This isn't exactly the most convenient way for us to create new types of objects. We'd like to be able to do things the way we do in C and C++, like this: a equals 1, t dot b equals 2, or perhaps t dot x equals 0, t dot y equals 0, or 0, t dot x equals t dot x plus t dot x speed. That stuff will be a lot more useful for us. And in fact, the truth about Lua is that it is perfectly possible. We can create objects like that using our tables. When we do t.a, we're accessing a variable inside the t with the string name a. So this is the first line there is equivalent to this line. This is really just the dot is really just a shorthand for using a string as an index in a table. So that's useful. We can now treat our objects exactly like the way we'd like to, with objects with dots to access our things inside the table. Now, that's all good, but let's say we want a really easy way to construct a table with lots of stuff. We want to make a bunch of new tables very quickly. We can also go with a setup kind of like this. Well, technically, where you should start with this is you can do indexes like this: x equals 0, y equals 0, and as you can see, your basic format here is inside the table constructor. You just include the key in square brackets and the value on the other side of an equal sign, and comma separating everything. And as you might imagine, there's shorthands, so if you just use a name, it will treat it as if it's a string index using that particular name. So I can replace this with that, and it's identical. Also, you don't have to use strings. Obviously, you can do something like this, make your array of identity, so you put in a certain number and get out the same number. But that's also a little bit overkill. What we can do is make just a list of items, like so. We can go 1, 2, 3, 4, 5, 6, 7, 8. And that will automatically pair each of these in order with each integer index. So this will become T1, this is T2, and so on. This is those in order. They don't have to be numbers, of course. This could be 1, 2, 3, etc. Now, your first reaction when you see this, if you're a good old C++ C programmer, what you might realize is I've made a small, well, it looks like a small error here, that I'm beginning with 1, and that's actually going to get paired up with 0. In fact, in Lua, and this is an oddity of Lua, most languages don't share in this, in Lua everything starts with 1 instead of 0. It does not follow the normal pattern of making everything start with 0, and that comes with certain benefits and certain drawbacks. The biggest drawback that I almost wonder why, I don't know necessarily think it's a great idea to have Lua set up this way, is that since it's communicating with C, there's sometimes an annoyance where Lua wants to say first index with a 1 and C wants to say first index with a 0, and so there's a miscommunication problem there sometimes. But that's something we can handle pretty easily. Now, that's all our basic table stuff, and there is also like more to do with how to construct tables easily, but that's what you basically need for constructing tables. Now we have a means of combination. We can make big complicated objects. Last thing we need is a means of abstraction, and by that specifically what we need, but when I say that, specifically what we need are functions. Functions are what we need. So in Lua, the way we make new functions is something like this. Function a end. Now this is a function, and it's a function that will take an argument and name it a, and then do nothing. We could make this function responsible for printing a and the word world for no particular reason. Now, if we do that, what we also need is a way to call this function. Right now we just have a function definition. How can we get at that function after we've defined it and use it? Well, we can just name it in a variable, like so. Let's call it h. Now, h is storing the function that we created here. This is a function constructor, constructs a new callable function, and then we store that function in h. Now I can call h as if it's a function with maybe the word hello, for no particular reason, and that will call this function that has been stored in h with the parameter hello with the parameter a filled in with hello, and then do this, which is print, which will by chance turn out the words hello world. Sweet. So now we have the functions, tables, and variables, and that's basically what Lua is made out of. Now there's a lot of nuances and interesting things we can do with that, but we're not going to get too much farther into Lua than that basic stuff. Next time we're going to see a little tiny bit more of Lua, and then we will know where we need to do work on our hybrid system here, and we will also start seeing what we can do with a hybrid system. So, this has been our short introduction to Lua. Next time see you next time. That's what I mean to say. See you next time.